scientists have dealt a blow to the theory that most water on Earth came from comets. Results from the Rosetta mission, which made history by landing on Comet 67P in November, shows the water on the icy mass is unlike that on our planet. The results are published in the journal Science. The authors conclude it is more likely that the water came from asteroids, but other scientists say more data is needed before comets can be ruled out. Since August, the Rosetta probe has been orbiting Comet 67P/Churyumov-Gerasimenko, and on the 12th of November its lander, Philae, made a historic touchdown on the object's surface. Although the robot's batteries ran out soon after setting down, it gathered a wealth of scientific data, and the Rosetta mothership continues to analyze the wandering ice mountain. This unprecedented, close-up look at a comet is helping scientists to answer the fundamental question of whether a bombardment of these primitive bodies brought water to Earth billions of years ago. And the latest findings, gathered by Rosetta's Rosina instrument, which consists of two mass spectrometers that sniff the gas that streams off the surface of 67P, suggests this may not be the case. Water on Earth has a distinctive signature. While the vast majority of liquid on our planet is made up of hydrogen and oxygen atoms, very occasionally a hydrogen atom will be replaced with a deuterium atom. On Earth, for every 10,000 water molecules, 3 deuterium atoms can be found. This water has the same physical properties as H2O, but it is heavier in mass. Professor Catherine Altway, from the University of Bern in Switzerland, who is Rosina's principal investigator, said, "This ratio between heavy and light water is very characteristic. You cannot easily change it and it stays for a long time. If we compare the water in comets with the water we have on Earth, we can definitely say if the water on Earth is compatible with the water on comets." The team found that there was far more heavy water on Comet 67P than on Earth. Professor Altway told BBC Radio 4's Inside Science program, "It is the highest ever measured ratio of heavy water relative to light water in the solar system. It is more than 3 times higher than on the Earth, which means that this kind of comet could not have brought water to the Earth." This finding adds to other studies that have analyzed water on different types of comets. Previous research found that water held in a class of comets that originated in the Oort cloud, a region of space that makes up the outer reaches of our solar system, also have a different signature to water on Earth. However, only 2 comets from the Kuiper belt, an area that extends to just beyond Neptune, have been analyzed, Comet 67P and another comet called Hartley 2. While these new findings show that the water on 67P is very different to water on Earth, observational studies from the Herschel Space Telescope have previously revealed that the water on Hartley 2 appears to be exactly the same as the water in our planet's oceans. However, Professor Altway believed that Kuiper belt comets did not bring water to Earth. She said, "The conclusion here is that in the reservoir of the Kuiper belt we have very diverse comets that probably came from different regions of the early solar system. We have light water in some comets and very heavy water in other comets. We have to assume the mixture of all these comets is something that is heavier than what we have on Earth, so this probably rules out Kuiper belt comets as the source of terrestrial water. Instead, she thinks that asteroids, dense, rocky objects that formed closer to the Sun than comets, seeded our oceans." She said, "We know already something about the characteristic of asteroids by studying meteorites, which are pieces of asteroids, and the characteristics of asteroids are very much like our water. They are also much closer to the Earth, so it is more likely that they hit the Earth than the very distant comets, which are beyond Neptune. However, some researchers say it is too early to rule out the comet theory and more data is needed." Professor Alan Fitzsimmons, from the Astrophysics Research Centre at Queen's University Belfast, said, "There is no arguing with this exquisite measurement. It shows the true value of going to a comet and doing your science there. The problem is that if you take the few Kuiper belt comets now measured and average them, you don't get Earth's water. We don't know how you just hit Earth with high deuterium to hydrogen comets and not low deuterium hydrogen comets. So more data are important, and specifically we now need to take a really close look at the icy asteroids and main belt comets between Mars and Jupiter. Professor Monica Grady said that the team's conclusions could be jumping the gun a bit. She said, the measurements that have been made by Rosetta are the gas that has come from the surface of the comet. The amount of hydrogen relative to deuterium changes as the gas escapes from the surface. This is why other instruments on the lander were going to make complementary measurements of the ice on the surface. We are going to have to wait to see what comes from Kozak and Ptolemy, Rosetta instruments, before we can say any more. But Dr. Conal Alexander, from the Carnegie Institution of Washington in the U.S., said that while it was dangerous to be too strident about one's conclusions based on only 2 data points, he said that asteroids did seem to be the best candidates for supplying Earth's water. He said, from meteorites, spectroscopic measurements of asteroids and even the fairly recent discovery of a few asteroidal comets, some types of asteroid contain quite a bit of water in clay minerals and possibly in ice.